What's up, party people? First of all, I want to say what's up, and thank you for watching. If you're watching this video, do me a great big favor. Go like, share, and subscribe to the channel. I want to say what's up, and extra down in here. Give me a second. Thank you for watching. If you're watching this video, do me a great big favor. Go like, share, and subscribe to the. All right, there we go. Sorry about that. But we are going to talk about the graphs of functions and rates of change in this particular video. And so we are in, for my students that are watching this, we are actually in lesson 9 of your workbook. Got to get my handy dandy workbook here. And so we're going to do about 4 different problems on this particular video. And I want you all to pause if you need to, do whatever you got to do. Let's see. Let me get my page up real quick. So let's go share this. And hopefully y'all can see this. All right. So with this, we are looking at on page 92, we're going to start with number 5, right? Now, this problem is a little detailed, so it may take a little while to go through this, but I want to make sure I get a thorough explanation of what's going on in this particular problem. So here we have, here we have, it says Noah and a sibling are going to make their favorite dinner. To find the ingredients, they use a rideshare service from their home to Rosa Parks Farmers Market. This graph represents function D. So function D is the name of the function, which gives their distance from the farmer's market in miles, M minutes since leaving his home. All right. So what we're saying is we have, in this case, D is the function. So notice the time since leaving home is minutes and the distance is in miles. Okay. So we can basically say that this is D of M. All right. And so now it says estimate the average rate of change for over Noah. Let me make this bigger. Let's clear this out real quick. Just a minute. Let's make this screen larger. Boom, that's much better for me. All right, so we have the function D, and so the distance as a function of the number of minutes since they left. Okay, so when I look at this particular problem, I want to make sure that we are mindful as to what's going on here. Okay, so it says estimate the average rate of change over Noah and his siblings' entire route. Now, real quick, let me explain this problem in just everyday language. So basically, this is a problem. Let's say 2 students, two siblings are trying to make something and they need to go to the farmer's market. They need a ride, so they call a Lyft or an Uber, right? And when we look at the function, notice this is distance from the market, okay? So we have a starting point here, which is 4 miles away from the market. So they live 4 miles from the market. Okay? They live 4 miles from the market. And then on the x-axis, you have the time since they left home. So it says here, this says it takes them 17 minutes. That's not good writing. All right, so it takes them 17 minutes to arrive at the market. Okay? So now, when it says estimate the average rate of change over Noah and his siblings' entire route, interpret this quantity for the context of the situation. Okay? So we have these 2 points. We have the time that they leave and then the time that they arrive at the market. Now, remember when we're talking about the rate of change for this function, we're basically going to have, when we look at the time, we're going to have f of 17. So I'm going to write that over here. So f of 17 minus f of 0 over 17 minus 0, okay? So f of 17 is 0 because we can see that from the horizontal axis or the x-intercept, right? So f of 17 is 0, and then f of 0 is 4. That is going to be the vertical axis or the y-intercept, okay? So that 0 minus 4, and then 17 minus 0. Well, 0 minus 4 is negative 4, and 17 minus 0 is 17, and that equals about negative 0.24, okay? Now, this is, so when we write this rate, it is negative 0.24 miles per minute, okay? So some of you may thinking, well, wow, it's a negative value, but this is a rate of change, right? So what this is saying is that the negative means that this distance, the miles per minute, is decreasing, right? So what this is saying is that every minute they are getting about 0.24 miles closer to the market. Once again, that negative 0.24 means that their distance from the market is reducing by about 0.24 miles per minute. And that sounds that should make the negative make sense because they're driving towards the market, right? So the distance from the market should reduce. It should get lower and lower the longer that they ride in the Lyft or the Uber. Okay, so that's part A. When we look at part B, it says what is the average rate of change from m equals 5? Okay, so that's right here, m equals 5. To m equals 7, and from m equals 15 here to m equals 16. Interpret this quantity for the context of the situation and provide a possible explanation for this average rate of change. So if we do f of 5 or d of 5, I said f and I should have said d. So if we do d of 5, okay, minus d of 7, and we could switch that up. We could actually say d of 7 minus d of 5. Either one works, okay? So d of 7 minus d of 5, right? And then it's over here 5 minus 7, or you could say 7 minus 5. Either way works, all right? So d of 5 is right there. That is 2.4. So we have 2.4. And d of 7 is 2.4 as well. Okay, and then 5 minus 7 is negative 2. Well, 2.4 minus 2.4 is 0. And so over negative 2. All right, so this basically is the rate of change is 0 miles per minute. Okay, so 0 miles per minute. I feel a sneeze coming on. If we do it the same way, d of 7 is 2.4. And then d of 5 is 2.4. 7 minus 5 is 2. All right, so this is still 0 over 2 as well. So that means 0 miles per minute. Well, when you look at this graph, if you look at this graph, notice that it's flat in that from the 5th minute to the 7th minute, right? So that means, remember, this is the x value, I'm sorry, the y value is not changing. It's staying the same. So what this means is that they're probably at a stoplight, right? So this could be that they're at a stoplight during this time. And then if we look here from 15 to 16, notice it's the same thing. It is the vertical change is flat, right? So it doesn't go up or down. It's the same thing. We don't have to do the calculations here, but if we did, it'll be 0.2, excuse me, minus 0.2 over 15 minus 16, which is 0 over negative 1. So during that time, that means they're not getting any closer to the store. So once again, these are two scenarios where they're most likely at a stoplight. I would say maybe from the 15 to 16 minute interval, they were at a stop sign, okay? Because it's a little shorter than the 5 to 7 minute interval, okay? But either way, the car is stopped. They're not getting any closer to the market during those periods of time. All right. Let's look at number 6. Number 6 has a couple different things on it. And we want to decide, so we have this graph here. We want to decide whether these particular, it says this graph represents Andre's distance from his bicycle as he walks in a park. Decide whether the following statements are true or false. So the graph has multiple horizontal intercepts, okay? Horizontal intercepts, so boom, there's one right here, and then there's one right there, x-intercept. So we know that is true, okay? A horizontal intercept of the graph represents the time when Andre was with his bike. That would definitely be true as well, because the dependent variable is the distance from his bike, because it says it says here Andre's distance from his bicycle. Okay, so if his distance is 0, he's with his bike. Here's where it goes a little in more detail. C says a minimum of this graph is 17 and 1. Okay, so 17 and 1, so boom, 17 and 1 is there. But that's not a minimum, because here we have the minimum at 1, 0, and we have a minimum at 27, 0. Okay, so these times where he's with his bike, those are the actual minimum. So this would be false. It says the graph has 2 maximums. Now, if you're not careful, it does look like it has 2 maximum, but technically, this is the maximum right here, because this value is slightly above that 8 feet mark. So this is going to be false. It does not have 2 maximums. And then it says about 21 seconds after he left his bike, he was the farthest away from it at about 8.3 feet. And that is correct. That's this point that we put right here. So this is going to be true. Okay. Be very, very careful with those maximums and minimums. You got to really look at the pictures in detail, because you can get tricked if you don't look close. All right. Let's go on to the next one. Let's look at number 8. All right. Number 8, you want to be able to match up these statements with these different features, or these features and these function notation statements on a graph. This is very important information, especially for your assessment for my students watching this. So when we look at these, we got a graph over here. We have a feature, and then we have function notation. We want to be able to translate between the 3. All right, so it says A. When we look at that one, the maximum height, okay? So the maximum height on the graph is here, right? So the input is 4, and the output is 16, okay? So here that would look like h of 4, okay? So I'm gonna draw a line, say boom, h of 4. All right, now it doesn't show the output in this particular function notation, but we can tell that the output is there from the graph. Okay. Second one says the minimum height. Okay, so where's the minimum height? The minimum height is about down here. All right, so what's the input halfway between 1 and 2? That's going to be h of 1.5. All right, so I'm going to draw a line here. Let's do a different color. Let's do blue. So that looks right there. Okay. When we look at the third one, C, height staying the same. Okay. Height staying the same. On this one, notice where's the height staying the same? It's down here. All right. So that's between 7 and 8. So h of t is the same between the time 7 and 8. So I would say this is going to be number 4. Okay. And then now it leaves with the starting height, which, as we can see, the starting height is here. Boom. So that would be h of 0 equals 7. Okay. Make sure that your features of the graph match with your function notation and they match with the description. Also, remember your time, your independent values on your x-axis. So make sure that you look out for that when you are matching these type of statements with the graph. Let's go one more. We'll do number 11. Number 11 says Lynn walks to school. The function D gives her distance from school in meters as a function of time in minutes since she left home. What does D of 10 equal 0? Okay. So here, when I have D of 10 equals 0, notice it says we got the D part, that's here, automatic. Her distance from school in meters as a function of time in minutes. Okay. So distance from school is output as a function of time in minutes, input. Okay. So this is input. This is output. Boom. So what that's saying is her distance from school. So what this says is basically her distance from school is 0 after 10 minutes. So in a nutshell, in simple terms, this means it took her 10 minutes to get to school. Now, we can say this in technical language where we can say something like, after 10 minutes, she arrived at school, something like that. But remember, the 10 represents the time, so that's 10 minutes. And then the 0 represents how far she is from the school. Well, if she's 0 meters away from the school, she's actually at school. I hope these are helpful for you. Remember, y'all like, share, and subscribe to the page, Young Gurus Math Tutoring. It's Mr. Harris. I got the solution to your math problem.